Let's now look at some example fingerprint analysis in a groundwater scenario. So this is a plan view showing groundwater concentrations measured in different monitoring wells. And there are two clusters that we see. On the left here, primarily it's PFOS, and on the right, it's primarily PFOA. They're clustered, they're different, they're far apart. So one conclusion, maybe initial conclusion, without a detailed analysis, is that we've got multiple sources. The reality is that all of these samples are due to a single source. Okay, and I'll take you through what's going on here. So why the pie is different. Let's now look at the individual concentrations, these hypothetical concentrations. You can see that the blue is the PFOA, the red is the PFOS. The concentrations decrease in the direction of groundwater flow. That's what we expect just based on groundwater transport fundamentals. But the rate of decline of these compounds is different, such that the ratio changes with distance. Okay. So why does that happen? Consider this zoom in of pore scale process. So the grayer the individual sand grains, this is in the saturated zone. All the pores are filled with water. And let's look at we'll call it a packet of water, if you will, right on the left. It consists of a combination of PFOA and PFOS. So let's say in that location, and let's assume we're looking at molecules as an example, or particles, whatever you want to call them. In this case, that water consists of 21% PFOA. As that water migrates to the right, some of those PFOA particles are sorbed onto organic carbon, and some of the PFOS are sorbed. But the PFOS, the red, are preferentially sorbed, right? They just have more affinity to the organic carbon. So by the time we now look at the packet of water here, now it only contains 33% PFOA. I'm sorry, it's increased to 33%. So it went from 21% to 33%. Similarly, as we move down gradient or down stream, if you will, we've got more preferential sorption, so that when we get to this point on the right, now we're talking about 67% PFOA. So there's been a fractionation, what it's referred to, a fractionation that's resulting in a change in the composition of in the groundwater. So whereas on the left, now going back to representation with pie charts, which is one of the ways this is done, a common way, on the left, we see a greater proportion of the PFOS. As we move down gradient, now we have a greater proportion of PFOA. And we look at it on a larger scale. In fact, the contrast could be even greater, which is what I showed initially. So this has nothing to do with multiple sources. It's really the signatures we see from a single source, but as a result of this fractionation. And typically what we want to do is we want to scale these pies according to the total concentration, so you get a more representative picture. So this is what's going on. This represents groundwater migration from a source with a composition of PFOA and PFAS. So the key points here are that these apparently different signatures are part of the same plume. It originates from the same source. Dissimilar signatures can occur due to this variable affinity to absorb to the organic carbon. The metric denoting this affinity is referred to as an organic carbon partitioning coefficient. In this case, that partitioning is greater for the PFOS than it is for the PFOA. That's why we see the composition change that we see. Now, as I pointed out earlier, there are numerous other factors affecting the chemical signatures that need to be considered. But I just wanted to point out two here because it always takes a lot longer to absorb this information than I think we often assume. And of course, these KLC values vary for different compounds. So you're going to see different ratios and different pie chart compositions when you compare different PFAS chemicals. So in closing, there are many factors that need to be considered for forensic analysis. Signatures cannot be evaluated in isolation. Many of us already appreciate that it requires a multiple lines of evidence approach. You have to have a solid conceptual site model. Two important factors that include the knowledge of groundwater flow or surface water flow direction and this issue of variable sorption or fractionation. Also, related to this, I want to point out that determining groundwater flow direction is sometimes not straightforward. I would say often not straightforward. And that fact warrants scrutiny of water level interpretations. That's by consultants. And I would say if you were a client, that's something you should really ask of your consultant. Hey, what about groundwater flow directions? Have these been evaluated carefully? So here's a couple of different processes, mechanisms I wanted to share, and I appreciate your time, and I'll take some questions.